Hey folks, how we doing? Back again. In this video here, this is going to be an addendum video, I guess, to the tow bar, not the tow bar, the Towhead video I did yesterday or the day before, I guess it was. And this is hopefully going to explain some stuff, at least the way I'm to understand it. And I'm going to take a little tip from Shop Dog Sam on this one, and I'm going to do a little fireside chat, as it were. Here's a fire in the wood stove, and in fact, I should close that. And I guess I'm going to sit right here and chat. So let me get that set up, and I'll be back with you in a minute. Hey folks, how we doing? Okay, so as I said, this is going to kind of be like an addendum to the Towhead video I posted yesterday, I guess. After I posted the video, I got a lot of response in the comments. In fact, my phone started, kind of dinging away with notifications and stuff pretty quickly. And overwhelmingly, most of the comments were, essentially saying, gee, Mike, you may have, worked on this thing, but you've essentially disabled the working function of it. So I said, well, you know what? In fact, one of the first comments that came in, I don't remember. It was almost right away as soon as I posted it. So I said, well, let's just let other folks weigh in on this, and we'll take it from there. I didn't really give the assembly part of it a whole lot of thought. Again, as I said in the video, what I was asked to do was to fix the problem of the the spread fork and the and the looseness of it. and again, they said they insisted that those are the bolts, those shoulder bolts are the bolts that were sent to them as a repair for that particular unit from the manufacturer, and that was what they were given with. And of course, there was no way they could get those to tighten up, even the way it was. I mean, they could get nothing out. There would be sloppy. My goodness, it was almost an eighth of deflection beyond the bolt, and the thing was already loose. So again, they had to do something, right? I'm sure we can all agree on that. Something had to be done. So again, I was tasked with doing something with it. So I went about doing what you saw in the video. And again, what I was to understand when they explained it to me was that there has to be a way to close that down, because otherwise all the force would be on that pin. Again, now I'm not positive that pin is either a 1/4 or a 3/16, but all the force would be on that pin, and of course, it's just not going to work. I mean, the guy would have to have, a pocket full of these things as he went out to go and get the plane. So that's obviously, you saw what I did. So I did the repair I did, and then when I assembled it, you saw me really kind of reef down on it. And yeah, that's exactly what I did, because I wanted to make sure that that thing would clamp on that flat attachment plate going into the head. And then I did the next thing. Actually, I brought it right over to the customer, and I gave it to him. And he said to me, he said, oh, he says, he looked at it and he says, oh, he says, great. He says, I'll adjust it and then bring it out to the ramp. Now this is the lead mechanic over there. This guy is very good at what he does. He's been doing this for years, specifically on the ramp and all aeronautical stuff, tugs, everything, the tugs, the bars, all the ramp stuff. So, as I said, as my phone started dinging with these comments saying, gee, Mike, you really messed this thing up, or essentially you disabled the function of it, I waited till a lot of them came in, and then towards the end of the day, I called him and I said, listen, I said, I'm just curious, what is the function of this thing? I said, and I picked his brain a little bit, and I says, so I said, first I asked, I says, what kind of airplane does this thing tow? So he said, oh, he says, this is a local, it's a private airport, it's not a commercial airport, there's no commercial flights in and out of there. He says, but no, he says, actually, he says, that's well, you saw the spread on that thing. I mean, you know. He says, no, that tow's a pretty big aircraft. He says, I said, well, like, what are we talking? He's like, oh, it's a jet, you know. He says, it would be, and what he told me was about a 50,000-pound aircraft. So I said, okay, and obviously, so we're not talking about a Piper Cub here, okay? So I guess we can agree on that. So then I said to him, I said, well, well, you know, let me see, you know, I said, let me understand this. I said, you did want me to make that thing so that it clamped down on the through plate, right? So that it would have. So he said, yeah, we need to have a bit of clamping force. He said, because otherwise, as I think I explained on the video, if there's no clamping force, all of the thrust, all of the weight, all of the inertia will be on that 1/4-inch pin or 3. Again, I'm not positive what that is. So I said, oh, okay. I said, and obviously, I says, that certainly won't work. He said, oh, no, you can't do that. You can't rely completely on that little pin. And then I discussed something else with him. I said, you know, again, because I've been working for this outfit for a while. It's a flight service company, and I've been working for them for a while. And I remember doing a job for them on a similar towhead, I don't know, maybe last year or a couple of years ago, where I had to take the towhead, the piece that you saw, and I had to set it up on the milling machine because that 1/4-inch, again, or 3/60, I'm not sure what it is, that pin, that shear pin, had broken off in the thing, and it messed up it's bushed. Again, I'm not sure I understand the mechanics of that. We'll get into that. And they couldn't extract it because it had kind of cocked in there, and they couldn't extract it, so I did have to set it up on the mill and plunge it out. Now, here's another bit of information. That pin, as I remember it, was not normally what you would think, like a cold rolled or a hot rolled, or it was some sort of sacrificial material. In other words, it is not as strong as a pin, a regular steel pin. It reminded me, because again, I looked at the snapped part, because it has to snap. It can't bend. It has to give easily. So what I'm trying to explain is it is of lesser strength than even the crummiest grade of steel, an A36 or a grade 2 bolt or whatever that might be. Because again, I guess they want it to cleanly snap. So it was some sort of a, when I looked at the broken part of it, it came out very easily by, you know, just plunging on it with an end mill. It was sort of, it reminded me of, I guess I want to keep saying sintered, but not necessarily a sintered, but like a casting, almost like a piece of cast iron, let's say. It was very grainy, let's put it that way. So it's not it's not a regular steel, okay? And again, it's either 3/16 or 1/4. Again, I'd be completely willing to come over and say let's assume the best scenario. It's a 1/4-inch pin, okay? So he said no. He says no. He says I do. He says I do adjust them. He says, and I have to go out there often and adjust, because there's other bars, other heads that are of similar design. He said, and he said no, they do need to be adjusted. He said, and those pins do snap. He said, and naturally we replace them. You know, he says they do get loose just from normal wear and tear. And again, keep in mind, if we can, they're using tugs, okay? These things are specifically designed to pull heavy aircraft. As one of the comments said, I've got my laptop in front of me here, and I'm trying to briefly run through read these and remember some of them, and again, I appreciate all of this. And somebody said, it's a really rough environment. Yeah, I've gone out there to look at jobs and things like that on the ramps, and yeah, these guys, as I responded to somebody, it's kind of a controlled chaos. And yeah, stuff is getting roughhoused, and again, there's these big tugs that weigh 10,000 pounds, 15,000 to pull these planes. This is what is necessary, and you saw the video I did on repairing the tow bar. It's a tough environment. So nothing's happening gingerly out there. Again, I'm sure we can all agree on that. It's a lot of hustle, and again, nothing's happening gingerly out there. This is a pretty involved, you know, it's a pretty busy environment, and I don't think people have time to go, you know, to take it nice and easy. Okay, so that's another point of information. So, so again, getting back to what he explained is that no, it is not to rely completely on that pin. There has to be some squeeze on that through plate, or again, the pin would just snap. It's just, that's the reason it came here, because it was loose to the point that it would no longer function. So, again, I don't know if we can agree on that or not, but that truly is what he described to me. And then later on, he said, I'll pull the pamphlet out on that and see if there's any information. I was wondering if there might have been torque specs or something like that. He said he could not find it when he pulled the literature out on that specific piece. So, again, so I asked him, well, what? He says, I just know how to adjust it so that there is a little bit of force on the, you know, on, let's call it on the squeeze, and I guess enough force on the pin so that it is still very much in the equation. Now again, as you witnessed, I didn't have any knowledge of that, and I wouldn't know how to set it up. So again, I just wanted to make sure that I had achieved what they asked me to do, that this thing would clamp and be able to take some of the force. Again, I wasn't thinking at all as to how much, etc. I wanted to make sure that it would clamp on that through plate so that it would do what they intended it to do. So that hopefully that'll clear that up. And again, I really appreciate you know, I'm not hurt or anything like that. Please, by all means, I love it when people send comments. And again, a lot of you are a hell of a lot smarter than I am when it comes to this stuff. And you know, I don't know anything about this sort of thing. And I'd like to actually point out, if you want to read the comments in the initial video. I actually had a fella comment in, and boy, this guy, wow, I mean, he did a lot of typing here for me. I really appreciate it. It's very nice of him. His name is Stephen Thompson, and and he says at the end of he posted a couple of times, and he explained that at the end of his thing, he is a mechanical engineer, and he explained exactly you know, the forces and how much strength and this and that. So again, let's assume, again, we know, because I inquired, we know that that pin is a lesser grade of material because it is designed to snap. So going by his this fella's stats here that he gave me, he's saying we could say the best scenario, even if it was a quarter-inch A36 material, the force, the shear force on that would be 2,117 pounds. Okay, so that's assuming it is a quarter-inch pin of A36 material. Yes, quarter-inch pin, A36 material. The shear force, from what he tells me here, is 2117 pounds. If it was the equivalent of a grade 2 bolt, that would make it 4,350 pounds. And if it was the equivalent of a quarter-inch grade 8 bolt, the shear force would be 8,835 pounds. Okay, so just going by that, I think, well, at least it's clear in my mind, folks, we're not going to be towing around a 50,000-pound airplane with a quarter-inch pin that could only possibly have a shear strength of 8,800. That would be the absolute best scenario, and we know it's not the case. Like I said, it's not even a grade 2 equivalent of a grade 2 bolt. Again, it is a material that is designed to snap. So based on that, I think I'm going to maintain my position that there must be some clamping force on that through plate from that fork. Okay, and I guess that's pretty much what I just kind of wanted to get that through. Again, I appreciate all the comments, I really do. And again, like I said, I know I had no knowledge of what I'm telling you right now. I wasn't thinking that when you watched me on the video assemble it. Again, I just wanted to make sure that I had achieved what, and by the way, again, when I gave it, he said, no, he says that we're good. He says it's back in service. He says everything's great. He says I was very easily able to adjust it. So again, I'm sorry I couldn't give you any specifics on that adjustment. Maybe he'll weigh in. He's a good friend of mine, and he sometimes watches my videos, so maybe he'll weigh in on the comments. But like I said, but the answer is no. It cannot rely completely on that shear pin to take the full load of the. I mean, just think about it again from a common sense point. Again, you've got a tug, you've got a long tow bar. I mean, just the plane is at rest, the tug is at rest, now the guy hops on the tug, he's got the tow bar connected to the tow head, and he takes off. And again, maybe again, a mechanical engineer, somebody, there is a, when you first take off, there's that, that inertia, that shock load, if you will. Again, I don't know what the proper term is for it. That shock load from taking off. So that's going to further, and I mean, that thing is completely at rest, and then the guy's going to take off. So I mean, that's it's going to take a little bit more force than towing it to get it to move. So again, I have to say that that's the case. Oh, and the guys that wrote in, I got a little visual aid. Maybe I'll my visual aid. I call this is my version of CAD, completely asinine drawing. But I'll come and zoom in on this. Some of the guys were saying about how the shear pin, which I didn't even think of, some great points about how the I just assumed that this thing was to a straight thing only, but some folks wrote it and made some very good points about how if it angles, it will also show it due to this. So I'll zoom in on this, and let me square that away, and I'll get you in a second. Okay, so here's my my version of CAD. And yes, what I wanted to say was, and again in the comments, some people, I hadn't even thought about this, and it's a very good point. I think Colin, Comp Edge, he read his comment. He made I think he wrote it out very brilliantly. Others mentioned it too. Was it Chalks or somebody? But yes, I hadn't thought about that. I thought the whole purpose of this slotting, although I didn't understand this one, I understood this one, that the idea was that by the way, those shoulder bolts, the thread is a half 13 thread on the bottom. The shoulder bolt itself, those are 5/8. The actual shoulder of that thing, it's a 5/8 shoulder bolt, and then the thread is half 13. And again, I'm sure there's a reason for all of that as well. So I just thought that the whole idea was that essentially those things, the bolts would come through, and roughly they're going to be centered, in these slots, and then again, when the thing gets overloaded, it shears the pin, and those things will slide back to the stops here. Again, I'm sure that's an equidistant amount, so that the force is now distributed on the backs of the slots, and now that pin is completely out of the equation. But someone, again, I think it was Colin, again, brilliant, great looking out, also made the point that it'll also alert the operator in a turning situation. I hadn't even thought about that. That's a very good idea. Yeah, that's that. And again, I guess that's why this one was designed. Is the pattern that it is. That this needs, essentially this will allow the bolt to pivot, but this one will make it quite obvious if it pivots. And I guess the reason it is this way is to make the larger part here, again, so that when that pin shears and the thing slides back, again, you're going to see a lot of daylight in here, even if you are on an angle or whatever, going straight or on an angle, you will. So again, Again, brilliant guys. So that's that. I hope that maybe that'll help, because again, if only for my own benefit, because I wasn't even thinking about that. I just assumed everything was happening in a straight line here. So so that again, thanks for the folks that alerted me to that. Yes. So okay, so that covers that. All right, so let me wrap this up. Hopefully that sheds a little more light, or gives you a little more idea of where my mind was at on this thing. And again, I want to say, first off, let me say thanks to everybody again who watches these videos of mine and subscribes. This is great. Again, this is an incredibly humbling experience, you know, that people are even remotely interested in what I do. It really is, and I thank you very much. I really do, honestly. I appreciate everybody who has been subscribing and watches and commenting. Again, please keep in mind, as always, I'm not the brightest bulb in the string. I'll do my best to answer, the questions as best I can and respond to the comments. I try to respond to all of them. I really do. I decided to make this video actually because to type all this stuff out would be very, very, very difficult. Would be a little bit difficult for me, because I'm not the most talented guy on the computer either here. So that's why I figured it'd be easier to just do a mass response here. But again, I appreciate this. I really do. And don't worry about offending. Some guys say hey, look, don't worry about offending me. Again, I'm all grown up. You go ahead and go ahead. It's no problem. Say it. It's fine. I mean, no need to just just need to abuse me or be mean to me. I don't know if there's need for that, but no, it's fine. Anything, like you said, you feel what you feel. You say what you're thinking as far as that goes, and that's fine. As they used to say on the radio, keep those cards and letters coming. Yeah, just by all means, comment. I'll do my best to respond. I try to respond as much as I can. So again, thanks everybody. I really do appreciate it, and like I said, hopefully that'll at least explain a little bit more of what I was thinking on this. And again, what I was thinking is that fix it the way, pretty much the way I did. Again, definitely an error was when I was reefing down on that thing. I understand that does not, that does completely cancel, I guess, the function of the pin, and that's not what we're after. Again, the lead mechanic, he explained that to me. But I guess what I was thinking was, yeah, of course, we're not going to pull airplanes on a little dopey, 1/4-inch pin here, So anyway, so that's that. And again, I thank everybody who continues to watch and subscribe, and I appreciate it. And again, hopefully I'll have some more stuff coming up soon. And as always, again, thanks for watching. If you enjoy what you see, please feel free to subscribe. And as some famous guy once said, everybody polka.